Let's do a problem. And this is where, especially for this first one, I say don't make it more complicated than it is. Also, sometimes it's kind of nice to draw a picture of what's going on with something like this. May or may not help you. So this basically says, what is the concentration in grams per liter? It goes on and says that they took sucrose, and it gives the formula for here, and it dissolves 32.3 grams of sucrose. So I'm going to put, this is my stuff that's being dissolved, 32.3 grams. I'm just going to go ahead and abbreviate that as sucrose, SUCC, is dissolved, and water is added so that the total solution volume, this is after the sucrose has been added, is 225 milliliters of solution. Okay, and so let me go ahead and go back to my question. What is the concentration in grams per liter? So question mark, grams, that would be grams of solute. What's the solute? The solute is sucrose, so grams of sucrose per liter of solution. So sometimes, you know, I am definitely a proponent in taking that G/L. What does that mean? Here's what it means. Grams of sucrose per liter of solution. What you're going to see here in a minute, and I said don't make it harder than it is basically we're going to take this mass, we're going to put it there in the numerator, and we're going to take this volume, we're going to put it in the denominator, and we're going to have to convert from milliliters to liters. How do we do that? What's the equivalency statement? A long time ago, we talked about liters and milliliters. Yep, there's 1,000 milliliters in 1 liter, and you're going to see that used here in a minute. So the solution, no pun intended, to this solution problem looks like this, where simply we're going to take that grams of sucrose, 32.3 grams of C12H22O11, divide it by the volume, 225 milliliters of solution. Now, I'm all about using units. If we were to stop there, we would have units of sucrose, grams of sucrose, units of grams of sucrose per milliliter solution. So the next term, what does it look like? Well, if we use that equivalency statement, 1 liter is exactly equal to 1,000 milliliters, and we're going to use it this way so that what? Milliliters cancel. Okay, we're left with grams of sucrose per liter of solution, and we're totally done. Okay, once you have the units that you're after, you don't have to add any more terms. You can't add any more terms, or you can come around full circle if you want to. So how many sig figs do we need to round this to? Yep, we're going to round to 3 sig figs because I have 3 there and I have 3 here, and there's no uncertainty brought by that relationship. So I get 144 grams of sucrose, or C12H22O11, per 1 liter of solution. Now, more commonly, it's written like this. And I'm fine if you want to go ahead and pack, to me, it's kind of packing back up your answer. Okay, so we can take these units, instead of doing that, we can write G/L, and then what the solute was. Okay. Now, I want to work a related problem. And for that problem we just did, I actually now want it in molarity. And I don't think I emphasized this before, but the symbol for molarity is a capital M. And what does that mean? It means moles of, in this case, sucrose per liter of solution. That's our target. Well, if it's okay with you, I basically want to piggyback on that 144 grams per liter. So we have this on the previous slide, and do you see how can we get from grams per liter to moles per liter? We can use the molar mass. Okay, I'll show you what that looks like, or what that feels like, sort of. So the molar mass, you're going to have to show this work. So you'll have a periodic table, 12 times the decimal number for hydrogen, that's the first term, plus 22 times the decimal number for, did I say hydrogen? Sorry. 12 times the decimal number for carbon, final answer, plus 22 times the decimal number for hydrogen, plus 11 times the decimal number for oxygen. and that's our molar mass. You get rounded to 2 decimals, 342.30 units are grams per mole. Now, I am definitely into unpacking, okay? You can't use it in your problem just like that. So to me, remember that means 342.30 grams of sucrose per 1 mole of sucrose. Okay? All right, let's see what this looks like then. Well, we're piggybacking on this solution we came up with in terms of grams of sucrose per liter of solution. Now, if we want grams to cancel, be left with moles, what does the next term look like? Yep, it looks like the flipped version of the molar mass. So if we put 1 mole of sucrose per 342.30 grams of sucrose, notice that the reason we did that is so that grams of sucrose will cancel. We're left with units of moles of sucrose per liter of solution. That's exactly where we want to be. Okay, by the way, we're all on the same page. This is the molar mass. All right, so how are we going to round that answer? Yep, we're going to round to 3 sig figs because we have 3 sig figs here. And actually, how many sig figs do we have there? We have 5 sig figs there. And we always go conservative, so it's going to be 3. So the answer is 0.419 moles of sucrose per liter of solution. Usually, though, if I'm working this problem, I'm going to write it like this: 0.419 capital M, and then say what the solute is. So that capital M, we say that's molar. 0.419 molar sucrose, C12H22O11. We say the molarity of sucrose is 0.419.